Okay, in our previous video, we talked about codominance. Now, we're going to talk about another variation of Mendel's characteristics, and that would be sex-linked traits. Now, in sex-linked traits, the key to understanding sex-linked traits is that the trait only occurs, in this case, on the X chromosome. Now, that doesn't mean to say that there aren't trait genes on the Y chromosome. There are. But the key to understanding this is there are there are genes that are on the X chromosome that aren't on the Y. Remember, the Y is a really, really short chromosome. So the key to understanding is that there is nothing on the Y notation. There's nothing on the Y letter, and we're going to practice this. So we'll get some practice for this. So females, remember, have two X chromosomes. Males only have one X chromosome. They're XY. So for sex-linked traits, we use the X and the Y. Only sex-linked traits. So I get some students that get mixed up. They want to use X and Y for everything. Unless I have specifically told you that these are sex-linked traits, you are not going to assume that immediately. You know, if we were to be at a college level class or an AP level class, I might give you questions that ask you to figure it out. But for now, I just want you to understand that unless it's sex linked, unless I tell you that, there's no need to do the X and the Y for the notations, for the symbols. Now, other than the X and the Y, everything else is familiar to us. If it's a capital H, it's dominant. If it or a capital letter, it's dominant. If it's a lowercase, it's recessive. Now I'm going to use the example hemophilia, and hemophilia is a blood clotting condition. It's a blood clotting condition, which means that if you have it's a recessive condition. So if you have big H down here, if you have big H, that means you have the normal blood clotting gene. If you have X little h, then that means you're going to have the hemophilia allele, the allele that causes hemophilia. Now, in this case, I'm telling you it's recessive. So you would need to have two little h alleles to have hemophilia. Remember, the Y chromosome carries no blood clotting gene, and that is the key to understanding this. The Y chromosome has nothing. So how would we write the phenotypes down? So let's look at the females. So ladies out there, unless you have been diagnosed hemophilia, you are all X capital H, X capital H. That is the normal blood clotting for a female. That's how we would write it. Let's say that you have X capital H, X lowercase h. Now we would say that we know you have normal blood clotting because you have the dominant allele, but you are a carrier. You could give this to your children. Now, we would say this of somebody that has a brown eye gene and a blue eye gene, you're a carrier, but carriers are often is a name used for like genetic diseases. You don't have the disease, but you're carrying it. You could pass it on. So you tend to hear that term for more genetic diseases. So female carrier could give to children. Now, what if she is X little h, X little h? That's the only way that a female could show the blood clotting condition hemophilia. Now, think about how that would happen. That would mean that that lady, X little h, would have one X chromosome from her mom. So her mom has to be a carrier, and the other X chromosome comes from dad, and the dad would have had to have it. So that's pretty rare to find an X chromosome from a mom to be a carrier and the dad to have it. That's the only way a female could have it. Now the males, you're either going to have it or you don't, because remember, you get one shot. The Y chromosome does not carry the gene. So it's only on the X that you're going to see it. So the X big H and then the Y with nothing. The X with little h, and then the Y with nothing. So if you have X with a big H, Y, you've got normal blood clotting. And again, guys, as you're listening to this, unless you've been diagnosed hemophilia, that's what you are. You're X big H Y, and then X little h Y. You would have hemophilia, and that's it. There is no other possibility. A male cannot be a carrier because he only has one gene. So there's no way for him to have a normal gene but carry another one. The Y chromosome does not carry it. So again, we're going to do one of these together, and I've started setting it up because these require some kind of good practice. So parental cross, the man with no hemophilia uh, is going to have a baby with a woman who is a carrier. So let's take a look at these genotypes. So the male would have to be XY, and I tell you that the man does not have hemophilia. He is normal, and so that means he would be X big H and then Y. Now, the woman who is a carrier, what would she be? She'd be X big H, X little h. And so we're going to distribute them just as before. We're going to say, here is the way the Punnett square is going to be, X big H, X little h. And then the guy, X big H, and then the Y is going to be alone, nothing. So I filled out the top of it. Why don't you guys hit pause and you guys can decide how to fill in the rest. All right, so you should have decided that this X chromosome is going to go down, X big H, and then the Y has to go over. So there's going to be one of our potential sons, and then let's drag the X little h, and then we're going to pick another Y. There we go. And so let's take a look at that. We'd have how many of these girls would have normal clotting? Well, one of the daughters, X big H, well, that means she has normal clotting. So that would be one with normal, one out of. Now, here's the tricky thing. I asked for a girl with normal clotting. There's only two possible girls, so I'm going to say 1 out of 2. Girl with normal clotting, that's going to be a carrier. That's going to be 1 out of 2. Because remember, there are only 2 possibilities for girls. There are no girls with hemophilia. Again, remember how that has to happen. The dad has to carry an X with it, and then the mom has to be a carrier. Now let's take a look at the boys. Remember, there's only 2 possible boys here. And in this case, we do have one boy with hemophilia. Remember, little h would be hemophilia. And then we have one boy with normal clotting. So 1 out of 2. So you're going to do the next problem. You're going to set it up. And again, why don't you guys take some time in class and in your Zoom and decide how you want to distribute this. So here's the cross, the man with hemophilia and a woman who is homozygous normal. Now take a moment to understand why I chose what I did. This is a female, XX, and she has both of the same, so that's homozygous, and she has capital letters, HH capital, and that means she's normal blood clotting gene. So we should set it up like this. All right, so you can hit pause if you haven't already. Okay, yeah, I'm going to keep yellow for both. So let me change that. So let me double check. I have both capital letters for the female and then the lowercase letter for the boy. Very good, or for the dad. And so let's distribute. We're going to have our X lowercase h. Now the standard is that the recessive goes on the second spot. So that would be there. And then we're going to fill in our X big H. And then we've got X big H for the bottom ones. And then our Y. And generally what you see is that you have the Y chromosome. Oh, sorry, let's make one more of these. And then you should be able to think about how you're going to fill in your chart. There we go. All right, so again, there's only two possible girls here. So girl with normal clotting. Well, they both have normal clotting, but both girls here are carriers. So 2 out of 2 for carriers. And no girls are hemophiliacs, so we should put a 0 there. And there are no girls that are just normal and not carriers. Boy with hemophilia, well, neither of them. So 0 out of 2. And then boy with normal clotting, 2 out of 2. So that is how we do our sex-linked traits. So again, just to recap, the most important thing to remember is that the Y chromosome does not carry any gene. It's very tempting to start putting in capital letters and recessive letters, but leave that Y alone. That Y chromosome, in the case of sex-linked traits, does not have that allele. And so what you're going to do is some more practice problems using these, and that hopefully will give you some good practice. So um, go for it. Go and do your homework.